Getting your character to move inside a game is very exciting and rewarding, and that is exactly what we're going to be doing in this video. First, we'll set up the animator to transition between the two animations that we have, the idle animation and the walk animation. After that, it's the fun part, and it's getting the character to move using the rigid body. And at the end of the video, I'm going to get the camera to follow the character. What you see right now is the idea behind what I'm trying to create in this game. This is what I have for it right now, and I'll show more of it in the next videos. But the idea of these videos is to show you how to make every single part so that you can use this knowledge in your own games. In this video, I'll be working with the character that we added in the previous video. And if you want this character asset, currently I have it on my Discord server, but you can check in the description for any changes. So in the previous video, we left off with our character going from idle animation to a walk animation. And I said that in this video, we're going to make those transitions using parameters. So let's go to the animations folder and open up the character one animator. So in here, here's the transition from idle to the walk animation. And some things that we want to do is, well, first we want to has exit time, turn that off. And in the settings, we want to remove the transition duration because we want to switch the animation right away. That's the settings they're going to have there. And for conditions, if you add a condition right now, you get a message saying the parameter does not exist. So the place where you add the parameters are right here by the layers, parameters. And the parameter that we're going to add is a float, and we'll call it speed. Now, what the idea for this parameter is when the speed goes above 0, then we transition from the idle animation to the walk animation. And that's what we can do by using the conditions. So in here, we can select the speed parameter. And if the value is greater, then we'll put in 0.01. And that is just for some little bit of forgiveness if the 0 is not actually 0. If the speed is going to increase about 0.01, then the idle animation is going to switch to the walk animation. Now we also want to switch from walk to idle animation if the speed goes close to 0. So for that, we'll make another transition and connect it to the idle animation. Select that transition, and we'll also want to do the same thing, has exit time turned off and transition duration also turned off. Add a condition, but this time we're looking for less than, and we'll use the same value, 0.01. So if the value is going to be less than 0.01, it's going to transition to the idle animation. Now we're going to control this parameter in our game logic, but to test, what you can do is you can drag this to the side right here for now, and we can go in and click play. And as you can see, as soon as the game starts, the character goes into the idle state. And if we actually change the value of the parameter to, let's say 1, you can see that the character starts moving right away. Change it back to 0 and he's back to idle. So that works exactly how we want it to work. With that, we are done with the animator. And now let's go and do some configurations on the character. So I'll double click on the character prefab. So we'll go inside here. And for our character, I want to add a rigid body. But before that, let's add a box collider 2D. So we'd have a collider. Let's edit it. And I just want it at the very bottom only. Something like that. But you can adjust it later. Now the other thing that we need is the rigid body. For the rigid body, I want to turn off the gravity scale because I'm not going to be using gravity in this game. And one more thing, for constraints, I want to set freeze rotation for Z to turn it on. We don't want the character to rotate around the Z-axis. And since we're going to set up the camera to follow our character, what I'm going to do is turn on interpolation so that the camera follow will work smoother. So that is all with the camera setup. And now we're going to start creating logic. But I'll be creating logic in both Bolt and C#. The C# version is going to be really quick, but I'll give more information what I'm doing when I'm doing the Bolt version. So for the two versions, I'm going to duplicate this character. One of them is going to be character 1, Bolt. So let's open the Bolt version because I'm going to be doing that one first. And I already have Bolt installed in my project, so I can go and find Flow Machine, add that in. And now I'm going to create a new macro and go to the macros folder. I'll name it character movement, click save. The first thing that I'm going to do is calculate the velocity based on the horizontal and vertical inputs and set that velocity to the rigid body. So let's go to edit graph. And inside here, to calculate the velocity, this is what I'm going to do. I'm going to get the horizontal and vertical input, create a vector 2 from those two, then normalize it to make sure that the movement in the diagonal direction is not going to be faster than the movement in the horizontal or the vertical direction. That's the reason for having the normalization. And after that, I multiply the normalized vector by a variable move speed. So let's go and create that variable move speed. It's going to be a float, and by default, I'll set it to 1. And this gives an option for changing the move speed for a character. After I do the multiplication, I connect it to a cache. And what the cache node does is basically calculates all of that and stores it in this node. So whenever I need it after that, I can access this value, and I'll know that none of this is going to be executed. This is important in my case because I'm going to be using it in more than one place. So to save me from recalculating this multiple times, I use a cache node. It's the same thing as creating a temporary variable in C#. So after I calculate the velocity, I can use that velocity to set it to the rigid body. So now we can connect to a rigid body 2D, set velocity, and pass in the value. And this graph right here should get our character to move around. So let's go to our scene, and we need to add the bolt character into our scene. Let's drop it in here. Let's click play, and there you go. Now the character is moving around using the velocity, but the animation is not changing. So that's the next thing that we're going to do, is to change the animations. So for animation, like I said, we need to change the speed variable. And we can do that by looking for animator, set float, because that's the type that we used. And the options that we have here is passing the name, and the name of our variable is speed. And then we need to pass in the value. I'm going to get the value from velocity. To get speed from velocity, what we can do is actually access the magnitude, and that's going to get you the speed from a velocity vector. But one thing to know about the magnitude, it does a square root operation, which is pretty heavy on the calculations. So if you want a little bit of optimization, instead of using get magnitude, what you can do instead is use the square magnitude. But at this point, it's not going to be speed, but it's going to be speed squared. So if you're fine with that, you can use that. And that's what I'm going to use here as well. We can test it now, and you can see as soon as we move anywhere, the animation changes. The last thing that we're missing is when you're moving into the right, the character is pointing the right direction, but when we're moving to the left, he's moving the other direction, but the walk animation is going to the right. So we want to flip it based on the direction that you're moving. And we can do that by using the scale of the x-axis. So let's go to our graph. And the first thing that we want to do is save the starting scale in the x direction. So for that, we'll create a graph variable, call it scale x. It's going to be a float. And now we can set the s scale variable to the x-axis of the get local scale. So now that we have the scale saved, we can create the logic for flipping animation. And this is the logic for that. So what I do is get the velocity in the x-axis. If it's greater or equal to 0, that means that we're moving right. It's going to use the scale x that we start with. So it passes in through the true, gets the current local scale, changes the x, and sets it to the local scale. If it's less than 0, that means we're moving into the left direction. So what it's going to do is multiply by -1, which is going to flip the scale of x to the other side. So let's connect that to our flow, and we can go back here, click play, and now we have our character rotating if we're moving into the left direction. Now, if you noticed, when I'm moving left and then I stop, he turns back to the right. If that's something you don't want, what you can do is go inside here, and in here where we have greater or equal, we can use the comparison node, and that one has lots more options here. But we're only interested in 2 of them. So the same one is going to be connected here. The change is when they're both equal, when it's actually 0. What we want to do is actually use a branch and break the connection right here. If they're not equal, then it's going to equal to false, and we will flip the animation. Otherwise, we're not going to do anything. So let's unpause it because we got an error. And now you can see that it keeps the last direction. So if that's what you're looking for, you can use this approach instead. Okay, so we are done with the Bolt version. Now let's go look at the C# version. I already created the file, so let me find it, character movement. And it also has a move speed variable that you can change in the inspector. So let's go and add the script and see what we have here. So at the very top, I have that move speed variable, and then I have the animator and the rigid body variables. Also right here, I have the scale X. So the setup is exactly the same as I did in Bolt. Now in the start method for C#, we actually have to find those components and connect them that way. Bolt does that for us, so we don't have to do that step. And right here, I stored the local scale X. In the update function, I calculate for the velocity. So I create a new vector 2, passing in the horizontal and vertical, then normalizing it and multiplying by speed. Setting the rigid body 2D velocity to the velocity that we just calculated, and then setting the speed float parameter of the animator to the velocity square magnitude. And the last part is flipping the animation. So getting the local scale, setting the scale X to the multiplication of scale X, and we do the same logic of velocity.x is greater or equal to 0. If it is, multiplying by 1. If it's less than 0, multiply by -1. And then setting that transform a local scale equals scale. Now, if you want to keep the previous direction, what you want to do is create an if and check for velocity.x to make sure that the velocity x is not equal to 0. So something like that, and put that block of code inside there. Let's go and test it out. Now you can see that both of my characters are moving. This is the Bolt version and this is the C# version. And like promised, the last step is getting the camera to follow the character. So for that, I'm going to use Cinemachine. If you want to install the package, go to Package Manager, look for Cinemachine and install it. Once you do, you'll get an option right here at the top, Cinemachine, and I'll click on Create 2D Camera. Once I create a 2D camera, I get a virtual camera right here. This is the CMVCam1. That's the virtual camera that Cinemachine creates, and it will control the main camera. That's why you can see this icon right here. When you select the virtual camera, in the options right here, you have the option for follow. You can connect the game object that you want to follow. So let's follow our Bolt character. Connect it here. One option that I want to change is the orthographic size. So I want to decrease it to 2. So it's closer. And that should be it. We can click play. And now we have the camera follow. That's pretty cool. So I'll export both of these characters that we just created and make them available to you guys. But that is it for this video. So if you found something helpful in this video, click on the like button, subscribe to my channel, and I'll see you in the next one.